Hello and welcome to another video lesson with Mr. Roman. Today we're going to be looking at angles of elevation and depression. And our warm-up here says the surface of a skateboard ramp is 20 feet long and the edge of the ramp is 10 feet off of the ground. What is the angle the surface makes with the ground to the nearest whole degree? So first, let's make a picture, or draw a picture of what this looks like. So we know that the skateboard ramp is 20 feet. So I highlighted that in blue here. And then we know that it's 10 feet off of the ground. So that's what we see in red. And what we're looking for is the angle that the surface makes with the ground. So in other words, this black line here is the ground. Here's the angle that it makes with the ground. And so here, if we're looking at the relationship between the angle, the 10 feet here, and the 20 feet here, this would be a sine relationship because we have the opposite leg and the hypotenuse of this right triangle. So we would say sine of this question mark degree is equal to the opposite leg over the hypotenuse. And to solve for this, we're going to do the sine inverse. And so sine inverse of 10 divided by 20 is going to give me 30 degrees. Now, within the angles of elevation and depression, it's all about perspective. The key issue is that understanding which perspective you have. Sometimes you're going to see the words elevation, or sometimes you'll see the word depression, and sometimes you won't. And so we've got to be able to understand what the concept of elevation and depression are. So let's look at that closely. When you are looking up, the angle your sight looks up is called the angle of elevation. So for example, if this were Mr. Roman here, and this is the ground, I'm looking up to the top of this building, that's an angle of elevation. Okay. And then if I'm at the top of a cliff and I'm looking downward from the horizon, so the horizon is straight across here in red, I'm looking downward, that's an angle of depression. I'm looking maybe into the water from a cliff. Okay, so when you're looking down at an object, your sight forms an angle of depression with the horizon. Okay, so in example 1, it says classify each angle as either an angle of elevation or an angle of depression. So again, it's all about perspective. So if we were at the star, if we had this perspective of the star, and we see angle number 1, well, we know that this is the horizon, and we're looking downward towards the person over here from the star. So we would call number 1 an angle of depression. Okay. Then if we were at this person and we were looking up to the star from the horizon here, this is the dotted line here for this person, this angle 2, we're looking upward, so that's going to be an angle of elevation. And then again, from the person here, if we're looking at the triangle, here again, the dotted line in the middle is the horizon, so we're looking downward for angle 3, that's going to be an angle of depression. And then at the triangle, if we're taking that perspective, here's the horizon here, the bottom dotted line. Angle 4, then looking up to the person, is going to be an angle of elevation. So in example 2, it says find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. We're going to round to the nearest hundredth if necessary. So here we see the picture. They've got the pole, which is 12.5 meters, and we see the shadow that it creates on the ground is 18 meters, and here's the sun up here. So here we want to know what angle of elevation we have from the shadow up to the sun. So we see that in this picture as angle X. So the relationship here, the trig relationship would be the opposite leg and the adjacent leg. So we're going to use the tangent relationship. So it's going to be tangent of the angle is equal to the opposite leg divided by the adjacent leg. To solve this, we're going to use the tan inverse of 12.5 divided by 18. And then when we calculate that, we get 34.777, which rounded to the nearest hundredth is 34.78 degrees. Example 3, it says the angle of depression from the top of a sheer cliff to point A on the ground is 35 degrees. So this point here is where we're looking at, and it creates an angle of depression here at 35 degrees. If point A is 280 feet from the base of the cliff, how tall is the cliff? So Here's the base of the cliff right here, and then it's 280 feet out to point A. So we're looking to find how tall this thing is, which is where the question mark is right now. So we know that in this situation, this is a right angle, so this is 90 degrees. Well, also, this here is a right angle. So we know that the missing angle here and this angle have to add up to 90 degrees. So we would say that the angle in blue is 55 degrees. And then, using our trigonometry, we would say that the side here, this is the opposite side from the 55 degrees, and this is the adjacent side from the 55 degrees. So this would be a tangent relationship. So we're going to say tangent of 55 degrees is equal to the opposite leg, 280, divided by the adjacent leg, which is question mark. Now to solve this for the question mark, we're going to take 280 divided by tangent of 55. And that's going to give us 196.058, which rounded to the nearest hundredth would be 196.06. And that would be in feet. Example 4 says a ski run is 1,000 yards long with a vertical drop of 208 yards. So the vertical drop meaning up and down here, and the ski run, which is this hypotenuse, that's 1,000 yards. It says find the angle of depression from the top of the ski run to the bottom. Okay, so here's the angle of depression with the horizon. The horizon is the dotted line. And we're looking to know what that is. Now, what we probably need to do here is we need to fill in a little bit more. This vertical line here is also going to be 208 yards. So that vertical distance over here copies over here, and it still creates a right triangle, as you can see. And then the relationship now between this leg of the triangle, which is actually the hypotenuse, and this leg, which is actually the opposite leg from where this angle of depression is, we're going to use the sine relationship. So sine of the question mark is equal to the opposite leg, 208, divided by the hypotenuse, 1,000. To solve this, we're going to use the sine inverse. So sine inverse of 208 divided by 1,000 is going to be equal to 12.005. And then we round that to the nearest hundredth, and we say that's 12.01. And that's 12.01 degrees as the angle of depression. And then example 5, it says Miss Faley was on a cruise. She noticed that there is a bird on the top of a cliff in the distance. If the boat is 650 feet from the cliff, and the cliff is 856 feet above the sea level, then what is the angle of elevation from Miss Faley to the bird? So let's draw a picture here. I think a picture would be helpful. We know that the boat is 650 feet from the cliff. So notice here, I've got 650 feet. Here's the boat where Miss Faley is, and here's the edge of the cliff. So 650 feet here on the bottom. And we know that the cliff is 856 feet above the sea level. So that's from the water up to the top of the cliff, and here's our bird. So we're looking for what the angle of elevation is here. So what we see here is the blue question mark for the angle. Now, in relationship to that angle, we see the 856, that's the opposite leg, and the 650 is the adjacent leg of this right triangle. So we're going to use the tangent relationship. So we would say tangent of the question mark is the opposite leg, 856, divided by the adjacent leg, which is 650. Then to solve this for the question mark, we use tangent inverse of 856 divided by 650. And when we hit enter on that, we're going to get 52.788, which rounded to the nearest hundredth would be 52.79 degrees as the angle of elevation that we're looking to find. And then in example 6, we see that an airplane is flying at a height of 2 miles above the ground, and the distance along the ground from the airport, for the airplane to the airport is 5 miles. So then it asks, what is the angle of elevation from the airport to the airplane? So again, let's draw a picture here. We know that the airplane is 2 miles off the ground, so that's their vertical height there. and it's 5 miles from that point on the ground to the airport. So that's this point. So 5 miles here, and this is the airport over here. So we want to know what the angle in blue is, which is the angle of elevation from the airport to the airplane. So if we see the angle, we know that this is the opposite leg of the triangle, and this is the adjacent leg of the triangle. So we're going to use the tangent relationship. So we're going to say tangent of the question mark is equal to the opposite leg 2 divided by the adjacent leg 5. And to solve this for the question mark, we're going to go tangent inverse of 2 divided by 5, which is going to give us the number 21.801. And then rounding that to the nearest hundredth, we're going to say 21.8 degrees as the angle of elevation from the airport to the airplane. And this concludes our video lesson.